Hey everyone, welcome to Book Overflow, the podcast for software engineers by software engineers, where every week we read one or at least some of one of the world's best technical books in an effort to improve our craft as software engineers. I'm Carter Morgan, and I'm joined here by my co-host, Nathan Toups. How are you doing today, Nathan?
I'm doing great. Glad to be on.
Great. And Nathan, you are not in your usual hometown of Colorado this week, are you?
No, I'm in Barcelona. We had a company offsite that we're doing with our team out here, and yeah, a little jet lagged, but I think I can hang in there.
Well, that's good. Plenty of time to read the book on the plane, huh?
Yeah, it was great. Actually, got a head start on next week too. So
there we go. Yeah, I'm excited about next week, and we're excited about this week. This week we read Refactoring: Improving the Design of Existing Code by Martin Fowler, with some contributions by Beck. If you are not familiar with Martin Fowler, he's a well-known name in sort of the software engineering publishing industry. He's a British software engineer. He's done lots of publications, most notably this book. And there's contributions, like I said, from Beck. He is one of the 17 original signatories of the Agile Manifesto. And he's also a leading proponent of test-driven design, which gets some shout-outs in this book. And you can tell that a lot of his thoughts on test-driven design are reflected in this book. I really enjoyed this book. I'm super excited to talk about it. Nathan, why don't you give me kind of your thoughts on the book before we jump in?
Yeah, it was really interesting to see that it felt very fresh. I think the revision that we read was from 2018, but it originally came out in 1999, and it was cool to see how much has changed and also what hasn't changed. I guess there was like an interesting snapshot, just because software engineering as an industry has really defined itself so much over the last 20 years. And so it was kind of cool to see the book evolve and change with that. I think unlike last week's episode, this one is much more of like a tactics Bible of software design. You know, a lot of tactics that are really deeply embedded in here. I think that's kind of cool what it did. And yeah, I also didn't realize that Beck created the term code smells. That was like a really interesting little side story of where
you hear that a lot, and then it's kind of funny to see the origin here.
Exactly. And I thought one of the things that I liked about the book a lot too is that there's a lot of duality. You know, he would give a technique and then he would give the opposite technique of okay, you want to take it from this to this new structure, and then here's how to reverse that. Here's how to take it from this structure and then move it back into this other one. I find this really helpful because you learn why, the whys behind it. In this book, I felt like gave us a lot of whys.
So let's talk a bit about the structure and give kind of an overview of the book for anyone who hasn't seen it or isn't familiar with it. So basically, this book is all about refactoring your code. And if for some reason you don't know what refactoring is, right, it's kind of the art of cleaning up your code, right, of taking your code and making it so it still has the same function as it originally started, right, but you're improving its flow, its readability, right? Martin Fowler has a great quote. I'm going to see if I can find it here real quick. He says, the true test of good code is how easy it is to change it. And so that's kind of the philosophy of this book, is that our code should be written in such a way that it's easy to read, it's easy to change, and it's easy to extend and add new features and also to fix new bugs. And so this book is kind of divided into two parts roughly. The first part of the book is kind of the philosophy of refactoring, why it's important, kind of the big picture. The second part of the book is a huge catalog of individual refactorings, right? I think this podcast is going to be focused a little more on the philosophy of refactoring. We'll touch on some of those individual refactoring, but the individual refactorings are basically techniques, right? He says, okay, let's say you want to. He has a lot of great ones about kind of polymorphism and how you could replace conditional logic with polymorphism with various classes and inheritance, right? He says, okay, if you were to do that, here are the steps and techniques I would do, right? Personally, as someone who's been in the industry for a decent amount of time, I found the catalog a little overly prescriptive, and some of the refactorings were so kind of obvious to me that to be totally honest, I skimmed the catalog, right? I didn't read.
Same.
Yeah, exactly, right. And I don't think, and if you look at, I did that by Martin Fowler's advice. He says, don't read this whole catalog word for word, just familiarize yourself with it. You'll know these patterns, and then if you want to apply one of these patterns in the future, come read it in depth, right?
Yeah, exactly. That's how I looked at it as well. I really enjoyed, like, each section had a little graphic of the transformation, which I thought was really useful. Like on a high level, you're like just like a little snippet. And
Uh-huh.
then on some of them, I would dig into the motivation, which I thought was good framing. But then when it got into the code examples, I remember when I was reading through it, I said, you know, if I ever felt uncomfortable with one of these, or maybe I wasn't as familiar with the pattern, going back and referencing this, I probably would really appreciate that deep dive into the code. But when I'm reading through the book, I was like, okay, this does not apply to me, or oh, this is very obvious, and just
Uh-huh.
skip it. Yeah.
Yeah. Well, I want to talk about first his approach to refactoring as a business priority, because I think if you were to pick up a book about refactoring, right, like all software engineers want to refactor, right? Like we come into a code base and say, oh my gosh, this is garbage. I'd change it. I do this. But the thing with refactoring, right, is we always say there's no time. We need to add features. We need to fix bugs, right?
Right.
It's working as it is. So how do I go about actually refactoring? And so you might be skeptical of a book like this. But his approach to refactoring is basically he has a couple different, what I think are very persuasive arguments for how, one, refactoring is a business priority and will make you a better software engineer. Two, how if you go about refactoring in the way that he suggests, you can perfectly slot it into your existing work without slowing yourself down. So I guess let's talk a bit about it being a business priority, right? He says the point of refactoring isn't to show how sparkly a code base is. It is purely economic. We refactor because it makes us faster to add features, faster to fix bugs. This quote really stood out to me. I was wondering, Nathan, what did you think about it?
Yeah, I think paired with another quote, which is refactoring is risky, is a really good framing that he gives, which is he gives all these ways of doing it in a successful way, right? Like the real purpose of refactoring is that there's no external change, right? No external behavior change to the code. But you've restructured the internal piece so that you can reason about it, or maybe it's cleaner or more maintainable. And that, I think, framing it within that business priority, he makes some really, really compelling cases of diving in as to why. Sometimes it's to understand things, sometimes it's because the business needs change, and to preempt that change in the business needs, you need to refactor, so then you can extend it, right? It's always like a separate step. It's like refactor and then add the feature development.
I love what you talked about addressing the changing business needs, because that was a little revolutionary to me, right? Because I think when you're designing software, right, there's always a question of, do we just build it to do the thing that it's supposed to do now, or do we want to make it extensible? Do we want to, plan for the future, right? But that leads to the case of, they call it YAGNI sometimes. You aren't going to need it, right? Where you kind of over-engineer your solution. And I find that balance difficult to achieve sometimes in my career. Martin Fowler suggests that refactoring is kind of the key to maintaining that balance, because he says, he's kind of discussing this strategy. He says, instead of speculating on what flexibility I will need in the future and what mechanisms will best enable that, I build software that solves only the currently understood needs. But I make this software excellently designed for those needs. As my understanding of the user's needs change, I use refactoring to adapt the architecture to those new demands. So this was freeing to me. I was like, I don't need to be some sort of all-seeing oracle who can envision everything that's going to change in the future. I need to build my software in a way where it's easy to change. And then as those needs come along in the future and I understand them concretely, I'll just change the software. So that was really, again, almost freeing to me.
Yeah. Some of these I think maybe I didn't have in solid words, or there's some intuition to some of it, but I think Fowler is just an amazing framer.
That's a good way of putting it.
This is the first book of his that I've read. I've read his blog over the years. His stuff is very easy to share. It pops up on Hacker News plenty of times. So it just comes along, sort of legend in the industry. Seeing his thoughts in long form was really great. I got to spend some time teasing it out and really understanding the sort of deeper philosophy here.
I think that's it's one of the guiding principles for us here at Book Overflow, right, is understanding those ideas in long form. And even if you're someone who's familiar with, it's like a hierarchy, right? Like a lot of us are probably familiar with Martin Fowler's tweets, right? And then you might be familiar with his blog posts, right? But really taking the time to read a whole book by him. And this book isn't very long. I think it's about 280 pages or so. Well, actually, it's like 350 or something. But a lot of it is the refactoring catalog, right? Which you can kind of skip. But anyhow, it only takes about a week to read. And that's a week you can really become acquainted with Martin Fowler. And I love what you're saying, Nathan, that he's an excellent framer. It kind of reminds me of what I think this is my favorite quote from the book. He says, "I'm not a great programmer. I'm just a good programmer with great habits." Right? Because I think a lot of us can kind of feel in this industry a little insecure. We can feel like we're not geniuses, or there's always someone out there who can just understand code better or understands time complexity better, anything like that. But to look at someone like Martin Fowler, who kind of openly admits and says, you know what, I'm not the best programmer in the world, but I have great habits, is so encouraging, because anyone can develop those great habits. And this book right here is a great way to develop those great habits.
Yeah. We talked a little bit about this like offline before this episode, was how neat it was, some of the patterns that he talks about with side effect free, alternatives to loops, like, moving to pipelines so you have filters and maps, really thinking about variable state, really thinking about, more functional patterns. And I think anybody who's started maintaining code has kind of stumbled upon these. Maybe you're a zealot, maybe you're not, but you kind of go like, oh, can I reason about the system? And I felt like a lot of this came back to that. It was like, you're struggling with this, here's how to reason about the system. And it just kind of give you a lot of building blocks to kind of be more confident about, changing the code in a way that you're like, okay, this is how it should serve me moving forward.
And what I love about this is we read A Philosophy of Software Design by John Ousterhout last week, which we really enjoyed. And John Ousterhout is also a proponent of this shouldn't take you much longer to apply these principles, right? But he does kind of say you should spend 10 to 20% of your time on investments, right? On strategically thinking about your code, right? Martin Fowler, I don't think if you asked him and said, will this take any extra time? He would say, no, of course, it's not going to take any extra time, right? I think, of course, refactoring is going to take a little more time. But he does say frequently that this isn't something you need to block out a chunk of time for. Like, okay, this sprint, I'm allocating 3 points to refactoring. He says, most of the refactoring I do is when I'm doing other stuff. He says, if I'm tasked with adding a new feature and then I go and look at the code base and it looks like a big mess to add a new feature, I don't figure out how to hack my way through the code base to, hot glue gun the feature on. He says, I refactor that code base. And then when it's easy to add a feature, then I add the feature, right? And he's kind of saying, listen, you have 2 approaches. One is to, again, figure out how to MacGyver the feature on, which is going to take you time and energy, or just go about refactoring, which will also take you time and energy. But really, at the end of the day, it's not going to be that huge a difference. And he also, I love his kind of philosophy to refactoring, because I think this is a big concern of mine, right? And before I read the book, this is how I thought, and I bet it's how a lot of other developers think, which is, what if something interrupts me halfway through? What if I set aside the whole day and say, okay, today is the refactoring day, but then I get paged or an urgent request comes in, right? And now I'm halfway through my refactoring and I've just kind of broken everything. And it's like, oh, well, that day's wasted now because I just have to abandon my changes, right? Martin Fowler says we're thinking of it wrong. He says, let's see, I'm trying to find the exact quote. He says, each individual refactoring is either pretty small itself or a combination of small steps. As a result, when I'm refactoring, my code doesn't spend much time in a broken state, allowing me to stop at any moment, even if I haven't finished. And that, to me, blew my mind. I was like I don't need to think of refactoring as this huge undertaking. Refactoring is really just a series of small steps. And so at any point during the refactoring, your code is always in a working condition. And so that was a big takeaway from me, which is, again, that's another way to think of refactoring. But also, while I'm refactoring, if I'm not doing it in such a way that roughly at any point the code is in a working state, then I'm refactoring wrong. My refactoring should be a series of small steps, not one giant undertaking.
Yeah, and this fits well within my discipline, right? Which I'm in platform engineering with a background in DevOps, and he gives a big shout out to CI pipelines, right? These continuous integration pipelines that are so critical, right? So crucial. I think, and we're probably going to get into this pretty soon as well, which is testing, right? Testing is a huge part.
Now's a great time to talk about that.
Cool. Well, good segue. So you kind of have to have confidence in your testing and your continuous integration pipeline, and it fits really naturally. Again, if you think of this as a book that was originally written in 1999 and then updated in 2018, this is probably one of the biggest revolutions that happened in software engineering over the last 20 years, is this move towards trunk-based development, this move towards continuous integration, continuous delivery, where we made it really easy to build and test and, sort of kick the tires on our code, both locally, but also in, whatever pipelines that we're pushing things up to. And it really pushes you to make smaller changes more frequently, right? It fits really well within this refactoring philosophy. And I guess if, as an engineer, I hadn't thought of it in this framing. I've been building out all the tools to make it easier to do CI pipelines, but I hadn't thought about deeply on what engineering practice complements modern CI pipelines. Well, this is exactly it, right? I can make these surgical changes, don't break any of the tests, and have a more maintainable structure that then I can build upon. That's really cool. That's a really cool way of looking at it.
I totally agree. And I think testing is one of those things that I was like this earlier in my career, that I would kind of hide behind the guise of like best practices. Like if someone says, well, why do we test? I say, well, it's best practices, right? And you hear that a lot, like best practices. And I believe that there are best practices, but you can't just say, oh, it's best practices and justify it, right? Like we need to know why we're doing what we're doing. And I think for some of us, maybe a lot of us, like we don't really know why we're testing, like what the point of it is, right? And Martin Fowler makes the case here, like the point of testing is to it's to increase our velocity, right? He says, whenever I do refactoring, the first step is always the same. I need to ensure I have a solid set of tests for that section of code. Although it takes time to build the tests, I end up saving that time with considerable interest by spending less time debugging it. So he's saying, obviously, I think when we think about tests, we think, well, this will be great if we break anything, we'll catch any bugs, right? But he's saying good tests like almost should never, I mean, this isn't really what he's saying, but this is kind of how I think of it, right? Like, even if your tests never go off, right? Like, they never break, that's not wasted time, because that means that you're able to move with that increased velocity. You're able to change your code. You're able to add new features to it. And with that solid test suite behind you, you're gaining that confidence that everything is still working as it should.
Exactly. I've talked about this before, the idea of giving a gift to your future self. Sometimes when I want to spend a little bit extra time, I'm like, okay, should I write the documentation for this or should I write a better comment? And I would say, well, me 6 months from now, thank me. Like, did I get this out of my head? But it's also, and he talks about this in the book as well, inheriting other people's code, right? If you have thorough test coverage, you also can help prevent unintended side effects of making a change that ends up breaking it because they didn't think about the system properly. Right. So if let's say you're doing table driven testing or something, and you have these like 15 test cases of ways that the function could happen, and then somebody tries to extend it because, maybe a ticket came open. Hopefully you give them a little warning of a side effect that could have come from it. Right. Then they have to deal with it. They either go, oh yeah, good point. Or actually, this test shouldn't be here because we actually want this functionality now. Right. Like it gives them this decision point to think about. And again, changing things with confidence, right? To me, that's what testing does, is I say, if I feel like I have good test coverage, then I can be more aggressive about a refactor with confidence that the external behavior, right, which is the big point of refactoring, the external behavior doesn't change. Yeah.
He talks about developing that confidence, like being able to run your tests quickly is a big deal, right? And so he recommends having, a local testing suite, or I'm actually impressed by how sophisticated cloud development environments are becoming these days. And so in some places you can run fairly complex integration tests in the cloud fairly quickly, right? If any of you are out there and are in an environment where you can pioneer that, I would recommend doing so, because it's really fascinating if you can develop in such a way where you can get your code up in the cloud quickly and then integrate it with all of your other systems quickly. But anyhow, when he talks about tests, he says, he's talking about refactoring, and he says, once I've made this change, this refactoring, I immediately compile and test it to see if I've broken anything. It's an important habit to test after every refactoring, however simple. And remember, he says that refactoring is a series of short refactoring. So he's advocating testing after maybe writing 2 or 3 lines of code. He says, mistakes are easy to make. At least I find them easy to make. Testing after each change means that when I make a mistake, I only have a small change to consider in order to spot the error, which makes it far easier to find and fix. This is the essence of the refactoring process: small changes and testing after each change. Because I think we've all been there, right? Where you build a feature or you do a big refactoring, right? It's a big undertaking. It takes you a couple hours to do. Then you run the tests and they're broken. And you're like, what broke? It should all work, right? But because you've done so much work over the course of those several hours, you don't know what went wrong. So he's saying, no, we need to be testing every 5 minutes, every 10 minutes, right? Because then if something breaks, the amount of changes we have to consider are so much smaller.
Exactly. Yeah.
Yeah.
And this actually feeds into, I was reading this and, nodding my head, and then he gets to the section on legacy code. And I think this is a good segue because a lot of legacy code is poorly covered with testing, or might even be untestable. And I was really happy that he addressed both of those, because I've been in that spot before. Because you're in this predicament where if you don't have test coverage, or the code is written in a way that's not testable, and by not testable I mean, maybe it's really, some wrapper function is really complex and assumes that it has things like a cloud specific database, or anything that like isn't easy to mock or swap out with other components. It's not written in a modular way. You end up having this really scary code base, and he comes up with some like pragmatic ways to address it. And some of it is that you just have to acknowledge that it is risky, right? That's the whole point. Refactoring without the test coverage, or refactoring in a way that you do have to start like doing decomposition of the system. You might have to give yourself permission to kind of be a little more aggressive, but then also weigh that with the sort of risks of the time investment that it ends up taking. And I think it's a good cautionary tale to show, okay, well, if you adopt all these patterns, you can move really fast, you can change things really aggressively, and then, hey, if you get this legacy code base, it's non-trivial, right? There's these. It could take months actually to do all the things that you have to do because of how much poor design and implementation was in place.
Yeah, let's talk a bit about poor design and implementation. Let's talk about, and I guess he makes an argument not even just against poor design and implementation, but maybe overly engineered design and implementation, right?
Yeah.
This idea that understandable code trumps performant code. I love this quote from him. Brevity is the soul of wit, but clarity is the soul of evolvable software, right? I think we have a tendency when we look at code that we don't understand, but it works, we feel stupid. Right? We think, well, obviously the engineer who wrote this is a genius because it's super complicated and it works, and I'm just too dumb to understand it. Martin Fowler kind of takes that burden off of you and says, no. If you can't understand the code, then whoever wrote it didn't write it in the best way possible. I just took a class at, I'm enrolled in Georgia Tech's master's program, and I took a class on human-computer interaction, right? And in that we read, I want to say this philosophy comes from the book, The Design of Everyday Things. We read quite a few books in that class. But the philosophy is basically that in human-computer interaction, right, there is no such thing as user error. If a user makes a mistake, that means that the interface is improperly designed. And so I kind of love that. Not so that we can pass the buck on to the people who write our code, right? Like if I can't understand the code was improperly designed, because obviously we have to improve our skills. But it's also, it's a burden on us, right? We talked about with the philosophy of software design last week, something that John Ousterhout says is like, if you're doing a code review and your coworker says, I don't understand this section of the code, like they're right. That means that you should either add a comment, you should rewrite the code, something, something to accommodate that. So, because I think I conduct a lot of interviews as part of my job, and we do kind of leak code style interviews at the companies I've been at. And sometimes you'll see candidates who are really into like the really short variable names, or like the giant ternary statements or something like that, thinking that like, I know like code golf is a real thing, but like we don't play code golf, right? There's not a tax on characters. You can kind of just be as clear as you want. And when I started out, when I'd see those kind of like leak code solutions, like, oh my gosh, like how can I can't understand this, right? But look, it looks so small and tidy. And I've come around on the thought of like, no. Don't be clever. Don't be cute. Just write your code in such a way that anyone coming into it can understand it immediately. Does that mean it'll be a little more wordy sometimes? Sure. But that is the sign of good software, that it's easy to understand.
Exactly. Yeah. That gets back to that. Will I think myself in 6 months? That clever code hardly ever meets that criteria, right? Especially if it's, to me, clever code is one of those things where you're like, you're in that, you're in a flow state, you're in some vortex, and you're like, I did it. I had this like epiphany. And it's, this is one liner, some dense logic or something. And then you go back, if you go back and look at code like that after 6 months, you're like, what?
Yeah.
What was I thinking? Like, where was my brain? And I forgot who, talked about this. Maybe it was in this book, that you read the code far more than you write the code. Maybe it was in,
it's a pretty common philosophy. That's one of those things like how we were surprised that code smells comes from Kent Beck. Like someone somewhere once popularized that reading code is harder than writing it, but I don't know who it is. We'll probably find out over the course of this podcast.
Yeah, exactly. And that's the thing is like, I actually have this conversation with my daughter. My daughter's like 8.5 years old, and she, we've been working on her handwriting. So her handwriting it can be pretty messy at times. And so we've been like working on it. And I was explaining to her that, when you write your thoughts down, it's for other people. Like you're giving this to other people because you want them to understand what is coming out of your mind. Right. And I think it's the same thing with not writing clever code, is that you want someone to look at this in the future and go, oh, yes, this was the obviously correct answer, right? I completely understand what they were thinking here when they did this. And so sometimes we have to take a step back and say, what did I optimize this for clarity, right? Did I do this in a way that was, again, a gift to my future self?
I have a buddy, he's like my best friend. We've known each other since we were little, and he's a genius. He is currently getting a math PhD at a prestigious university. And I thought he wanted to be a professor for a while, has lately decided he's going to switch more on the industry track. And so that involves learning how to write some code, right? We did a bit of coding classes in college together, but he's got to get more into it. So he's been doing some of these coding interviews, right? And they've given him some take-home exercises, and when he's allowed to, he likes to review them with me just because I have a little more experience in writing code. And I'm telling you, this guy's a genius. Like he dragged my body across the finish line in our data structures and algorithms class back, in sophomore year. But he shows me this code, and I just tell him like, Nathan, only that's funny. Yeah, his name is Nathan, like you, wow. Nathan. But I say only a math PhD could have written this code. It was a brilliant solution to the problem, and like I had to kind of parse over it, and I was like, okay, once I see what he's doing, I'm like, yeah, like he cracked this algorithm immediately, right? But the code was insane, right? Like, and it was just crazy to see that like it was performant. It was the fastest way you could do it, but I, an experienced software engineer, had to kind of like puzzle over it for a couple minutes before I was like, okay, I see what he's doing here, right? So that works totally fine in the interview for the kind of place he was interviewing at. But I told him, I was like, listen, I'm not your interviewer. I don't know what they're going to take. All I can give you is my opinion as a software engineer. But like, if you try to check this code into our shared repository, I would ask you to rewrite it. And I kind of gave him some tips on what I thought he should change, right? And that's, but again, when I came to that at first, I was kind of like, gosh, like this guy's just way smarter than me. not only is he smarter than me at math, but he's probably a better software engineer because look at this code he could write. But reading this, this book, Refactoring, I felt a little more justified in my initial opinion of like, well, I'm not saying the code was bad because obviously it worked. But what I am saying is that, I'm a fairly smart guy. And if I can't parse what it's doing pretty quickly, that means there's room for improvement. That doesn't mean that I'm doing a poor job comprehending it necessarily. That means that he could write it a little clearer. And I think the important thing with that philosophy is that it equally applies to you. If someone comes and looks at your code and says, I don't understand this, that doesn't mean they're an idiot. That means that you could do a better job writing it a little clearer.
Yeah, that's fascinating. This actually gets me to thinking too of, there's this relationship between the culture and norms of your team as well, right? Like you would imagine if there's folks working on, hardware drivers for Linux, they're probably going to have, some dense logic and some other norms that are completely normal to them. It's maybe even some form of code that they can completely recognize and feels very natural. And again, it's that thing of, am I being clever right now? Or is it the way that we express this in this domain that we're in just kind of dense to an outside observer, right? Am I communicating this to who my peers who do the code review would say this is acceptable or this is the norms that we have? Because I've noticed this. I've done, a lot of DevOps and MLOps and lots of different coding pipelines. And it was shocking to me. Also, I worked at a startup that had a bunch of database folks, like folks who'd like worked on low-level database C++ stuff. And to see the cultural norms across those teams, who they hired for, what their coding standards were, is shocking, actually. You look at a data scientist and the way that they kind of write code, very different than someone who's doing site reliability engineering or optimizing for resiliency. So yeah, that's really fascinating. And yes, I've definitely seen those math whizzes who I was just like, you're on a different planet. I appreciate you exist, but.
And I love what you're saying, Nathan, about how you have to consider your team culture and kind of the water you're swimming in, right? I think, let's say you follow us, on this podcast and you decide, okay, I'm going to also read all of these books, right? I think I would have done this, a few years ago when I was earlier in my career, right? I think if you got to have humility as you learn all of these new things, and you have to make sure that you're still fitting in the shape of your team, right? You can't just come armed and say, well, I read this book and this guy's got tons of experience and he says we do it this way, so we got to do it this way, right? You need to figure out what ideas and philosophies you can take from these books and how do you apply them into the team you're currently on, right? I like what you're saying, Nathan. Like, people who are doing like low level systems work might have just a density of code that might be really intimidating to someone like me who comes from like more of a standard distributed computing REST, paradigm. That doesn't mean that either one of us is wrong, or you can also imagine someone who their job is they teach CS 101 at the local community college, right? Like they would need to write their code in such a way that a beginner understands it, right? And we're all just operating in different fields, right? I saw, I think it was a Reddit comment of all places, right? Where he basically said that like, as a manager, right, you can kind of imagine your team members as different blocks or puzzle pieces or shapes, right? And your job is to cover the most surface area possible with your different shapes, right? And he kind of compared being like a difficult but genius coworker to being like a really big shape that's in a really weird shape, like jagged edges and blobs sticking out, right? And he says that you might be big and in a vacuum you could cover more surface area than a smaller shape, but really as a manager the shapes I need are ones with square edges, right? Rounded corners, familiar noticeable shapes, because I can fit those together and I can cover more surface area more. And so he's basically saying that it's better to be, obviously you want to, if you can think of the size of your shape as how much you know and how good you are at what you do, we want to be trying to increase that size of our shape all the time. But we also want to pay equal attention to the shape of our shape, right? And are we a kind of shape that can fit easily with other shapes, right? And so I think by reading these books, we're doing that. We're increasing the size of our shape. We're understanding our field better. We're gaining these new sort of tactics and philosophies, but we have to be careful that we are not adding jagged edges and strange blobs to the outsides of our shapes, because if we become difficult to fit into the team puzzle, then we're actually becoming less helpful instead of more helpful.
Yeah, well stated.
It wasn't me. Again, it was some random Redditor. We'll have to find him or
that's
her
great.
and credit them.
One of the wonders of the randomness of the internet is that you get little nuggets of wisdom sometimes from the strangest places. I like that though, because I think we've all worked with those, kind of difficult folks who take up a lot of space in the room. I might have even been that person before. Hopefully I've filed down some of my rough edges. I think that's an interesting way of thinking about it too, which is, am I a good team player? Like, can I work on a team in which a manager goes, yeah, if we put him here and her there and, these people work together, we can pull this thing off, right? Instead of being like, ooh, we're going to have to deal with this guy.
Yeah. Well, and I think refactoring is one of those places where how you go about it can really define whether or not you're a team player, right? And I think Martin Fowler approaches it in a way that really could make you a great team player. Because I think if you, again, the non-team player way of doing refactoring is saying, no, I can't help with that feature. I can't help with that bug. I'm refactoring, right? And don't bother me. I need to block off time on my calendar because I'm doing the busy, important work. But then heaven forbid you get sick or something happens in the middle and then all that work is abandoned. And someone thinks, yeah, that's Carter. He's the guy who says he's refactoring all the time, never actually finishes it, and really is just telling us our code stinks, right? Like, that's not a good team player way. Right. But Martin Fowler approaches it in a different way. And he says, again, like we say, it's a series of small steps. He just refactors as he goes. And then if you're doing it that way, now all of a sudden you're the good team player that every time you're checking in a fix for a bug or a small new feature, something like that, people are looking and saying, wow, he got the bug done. He also really cleaned up the code base. Like, this is a lot more understandable than it was before. And yeah, so I think by really adapting Martin Fowler's refactoring philosophy can, like we're saying, it's not only increasing the size of your shape, but it's filing off some of those jagged edges.
Right. Yeah,
well, I think. Yeah. Oh, go ahead, Nathan.
No. I was actually thinking about in real life. Sometimes when we're unloading the dishwasher, my wife and I, we have different philosophies on how so the cups will go in the cupboard, right?
Yeah.
But I will periodically refactor the order of the cups because I'm like, okay, well, these like taller glasses, if they're grouped together, then you're not having to like dig around and find where the tall glass is versus the shorter glass. And it takes it's a really short sorting operation. But if you do it every once in a while, I mean, the disorder kind of creeps in over time. But if you sort it, it actually makes it much easier for everybody to engage with the cups that are on the shelf. And I didn't have to like stop the world and be like, okay, we're not going to cook meals for 3 days while I sort all the cupboards. I can be like, okay, I'm going to do this one little piece. I can do this one little piece, and it takes me like 5 minutes. And yeah,
this is why you got to tune into Book Overflow, because you don't just get software engineering knowledge. You get marriage advice, you get parenting advice, right? You get travel advice. This is great. I'm not doing my part this week. I've also got kids and I'm married, and you'll get my life lessons in a different week.
That's hilarious. I'm sure my wife, with me traveling this week, my wife is probably like, it's so much easier to clean up the kitchen.
We'll do a special episode one week where it's just our wives talking, and they'll be like, what? Yes. Those guys? No, they're morons.
That's great.
Well, Ethan, I think we're about ready to wrap up, but I don't want to ignore anything that you might want to talk about. Is there anything else from the book that really struck you before we maybe move to wrap up?
No, this hit all the main points. I think it was really cool to hear your perspective on this as well. I think, you can easily read these books and you find the nuggets that are important to you. It's really great to hear someone else. I think this is one of the reasons I'm loving the format of this podcast is I get an accountability buddy to read these. And then I'm like, oh yeah, that's really cool that resonated with you. So it's been really neat.
That's the dirty secret of this podcast, is really we were both like, hey, we want to read a bunch of books. But if we're going to read them, we need someone to keep us in line. And if we need someone to keep us in line, we might as well record it. And that's how you make a podcast.
Exactly. Yeah. I'm amazed at how many moments in my day I have time to read when I thought was like,
yes.
I don't have time. And I'm like, oh, I actually have a lot of time. So
yes. And, you know, my wife and I talk about this a lot, right? Which is kind of like, some days I'll get like really into a project I'm working on, right? Like, you know, just like a personal project. And then, you know, because you spend all day coding and working, right? And then, you know, I make sure to take time off with the kids, and then they go down. But then sometimes I just get right back into coding and working. And then I kind of have to ask myself, like, oh, should I have done that? I mean, should I be spending, you know, this is so much time working. And what I have to ask myself is like, what is it replacing, right? And I'm shocked how often the answer to like what my coding is replacing is like, it's replacing Netflix, or it's replacing like Stardew Valley. And I love Netflix and Stardew Valley, right? But are those really engaging, fulfilling, worthwhile pursuits to do all day, every day? I don't think so, right? And so I think if you, in the same way, like if you're working so much that like you're missing family activities, you're missing unique opportunities, like that's a problem. But if you're replacing, you know, like kind of nonsense with a little extra work on a personal project, I don't think that's so bad. And it's the same with like reading, right? Because I was kind of the same way. I'm like, I don't know if I'm gonna have time to read all of this. But it's like, what am I replacing? Like, I'm usually just replacing Twitter time or Reddit time, right? Yep. And I've been shocked too that if you kind of just think like, okay, I'm just gonna do like 30 fewer minutes of Reddit or Twitter each week or each day, you'll find the time to read.
Right. And you look back in 10 years and you go, wow, I've read hundreds of books.
Yes.
Or it's like, oh yeah, I wasted all that time looking at YouTube videos and
yeah, absolutely. Well, so I think, Nathan, we like to do at the end of the podcast, we have to talk about who we would recommend this book to. So Nathan, who would you recommend this book to?
Yeah. So one of the obvious answers would be, you've kind of casually read Fowler, you know, on Twitter or through his blog. This is a fantastic long form book to dive into. So if you're a Fowler fan, definitely read this book. But I also think it's a general purpose reference book. You know, I have the Kindle version. I think I'm going to buy the physical copy because it would be really nice to just be able to like pop it open to the section and look at these these examples that he's got. And then, yeah, any individual contributor, you know, it's again, much like the last book, I think there's a lot to get out of it for beginners. I think there's a lot to get out of it from somebody who's been doing this a while and goes, oh yeah, I hadn't thought of it that way. And so, and anyone who's interested in the craft or interested in Fowler, I guess that's the my long answer.
I would agree, and I would also sign off on getting the physical copy. I might do that myself. I'm a huge Kindle fan. I honestly think it's one of those beautiful devices we've designed. I love my Kindle, but reading through it too, I'm like, there's value in having the physical book, especially with this book. So I agree with everything you've said. I think I would recommend this to anyone who is working with large legacy code bases and feels intimidated about making changes to it. I think this book will help you identify kind of a good pattern of attack of, you know, okay, how can I develop tests? How can I refactor in small chunks? You know, how can I go about it in a way where I'm not really ever breaking the code? I think this will help you feel more confident when tackling a big code base like that. I would really recommend this to anyone who has been stuck in what I've heard termed as a feature factory, which is one of those places you see it a lot at like, especially smaller startups where like, it's just you're cranking out feature after feature after feature. Like, hey, this customer wants it to do this thing under this condition. And so like you usually just write like an if statement that says like, if customer ID is equal to that customer, then do this, right? And your code base becomes this big jumbled mess of spaghetti. Like if you're someone who works at a place like that, I would really recommend reading this book because I think it's going to teach you how you could approach adding those features and fixing bugs in a more productive way. And I would also really, really recommend this to anyone who either doesn't understand or is skeptical of the idea of unit testing. We didn't quite get to it, but Martin Fowler has some great thoughts on how much you should do testing. He is not a 100% code coverage kind of guy. He even talks about how there's diminishing returns in the tests you write. And if you try to write too many, you might wind up writing too few. And it's better to write some than none. So he kind of has an interesting philosophy on like don't get discouraged. Right, as many tests as you need. But I think if anyone is kind of like, I don't get why we do unit testing. I remember when I had my very first internship and I had never really done unit testing, and I kind of asked like one of the senior developers, and I was like, why do we need to do unit testing? Like, it works because I click the button and it does what it's supposed to. And so if you're still kind of in that philosophy, I'd really encourage you to read this book, because you're going to see that unit testing isn't just one of those chores we have to do because it's a best practice. There's real added benefits to increasing your velocity of development. So yeah, if you're skeptical of testing in general, I'd really encourage you to read this book, because I think you're going to be exposed to lots of really interesting ideas.
That's awesome.
All right. Well, once again, the book is Refactoring by Martin Fowler, with contributions by Kent Beck. I think we both can say we really enjoyed the book. Isn't that right, Nathan?
Yeah, highly recommend. It's definitely going on the shelf.
Definitely. Well, thank you so much for tuning in. We really encourage you to continue tuning in to read the books as we read them. We'll have to get around to this, but I'm sure one day we will publish our calendar somewhere, and so you can see what books we'll be tackling on what days, and so you can be prepared when the podcast happens. We're setting up the social medias, but I believe you'll be able to find us on Twitter and Instagram soon. You can email us directly right now at contact@bookoverflow.io. So if you found this podcast particularly insightful, even if you found something you would like us to correct, or thought that we had it wrong, please contact us. We'd love to hear from you. And depending on schedules and how you feel, maybe we can even have you on the podcast to discuss a book of your choosing. But we had a great time reading this book. We thank you so much for listening, and tune in again next week.
Talk to you soon.